Hello again, and welcome back to the Latex Modified Concrete Working Group and our continuing series on the use of VESHPLMC. Thanks for joining us. I'm Pat Martins with Bridge Preservation and Inspection Services reporting for the working group. Today we're going to be looking at a product that is ideal for rapid restoration of bridge decks, such as when work needs to be completed over a weekend or even in an overnight application. That is the use of a rapid setting overlay. So far, our discussion within our video series has mainly revolved around the use of latex with a conventional Portland cement concrete using a Type 1 cement. We can use other cements, though, to accelerate the process when necessary. A high early strength LMC, for instance, utilizes a Type 3 cement and can achieve high early strengths within a 24-hour wet cure and 24-hour dry cure period, which is half that of the conventional latex concrete curing period. However, can we gain even higher strengths faster? Absolutely. And that is with a class of high-performance concrete referred to as very early strength high-performance latex modified concrete, or VESHPLMC. You may even hear it called on occasion as rapid setting latex concrete, or RSLMC. The mix designed for a VESHPLMC is essentially the same as that for a conventional latex mix with Type 1 cement, with the exception being in the cement type. VESHPLMC utilizes a calcium aluminate or calcium sulfoaluminate cement, which provides for rapid hardening of the concrete. It has a great compatibility with the latex modifier and provides a very durable, long-lasting concrete. When selecting a cement, always check with the latex producer to verify that the cement is compatible with the latex being used. The cement is added in at the same rate as with normal latex concrete batching using a 7-sack mix. The amount of latex is the same, 24.5 gallons per cubic yard. Aggregate proportioning is essentially the same too. VESHPLMC does require a little more water, though, for the hydration process. Typically, the water-cement ratio for VESHPLMC will be specified at a maximum of 0.42. The slump for testing purposes is generally allowable at between 6 inches and 9 inches. The mix will discharge in a very fluid condition, but quickly firms up. VESHPLMC can be expected to gain compressive strengths of 2,500 psi or more within 3 hours during warmer temperatures, with a minimum one-day strength of 3,500 psi. A retarder such as food-grade citric acid can be used per the cement manufacturer's recommendation to help temper the set time and allow a little more working time for the finishing. As with normal HPLMC, surface preparation and deck saturation prior to the pour is critical. Generally, with a VESHPLMC installation, as the concrete finish machine completes the strike-off and drag finish, the surface is immediately ready for texturing and curing. So the texturing and curing operation needs to follow the finish machine very closely. Curing may be even more critical with the VESHPLMC compared to conventional LMC. A wet burlap cure of a minimum of 3 hours is required. The burlap must be well saturated and covering the entire surface area. White polyethylene sheeting also needs to cover the burlap during the wet cure period. It may be necessary to add soaker hoses too. No dry curing is required, though, with VESHPLMC. Another consideration for VESHPLMC pours is the ambient temperature. At temperatures below 60 degrees, it may take longer than the normal 3 hours for the concrete to gain the necessary strength, so be aware of that in cooler applications. VESHPLMC provides the same benefits as a conventional installation with a Type 1 cement. The mixture provides a very dense, impermeable surface, has great adhesive qualities, and is durable and long-lasting as an overlay system. Especially important is the ability to get traffic back onto the bridge deck in short order. These installations are ideal for weekend type projects in conjunction with hydrodemolition surface preparation. Entire bridge decks can be rehabbed within a 48 to 60 hour window over a weekend, eliminating long-term traffic disruptions. In extreme cases, closures and pours can be done in overnight applications, where the lane closure time may be limited to only 10 to 12 hours or even less. Just remember that less available work zone time results in lower production rates and output. On properly prepared and sound surfaces, the installation can be expected to gain upwards of 25 years and beyond of service life. The first VES HPLMC installations were done back in the mid to latter part of the 1990s. Their popularity is only increasing as traffic demands dictate less traffic disruptions. And that wraps up our discussion of VES HPLMC. I hope that you found this information to be helpful and are ready to give VES HPLMC a try. Join us next week as we are going to take a look more closely at latex and its use in HPLMC. If you have a specific question on VES HPLMC, you can drop us a line at the working group's email address at lmcwg@bridgepreservation.net. Follow us on the LMC Working Group's social media sites too. Hey, let's continue to extend the life of our bridge decks by preserving them with HPLMC overlays. See you next time.